Assalamualaikum. We are from the 3IQ. So now, in this video, we will discuss about the application of differentiation in topic related rates. Now, I will introduce our group members. Before that, I will tell you a little bit about our details. So, we are from CS110, which is Computer Science. Our course code is M80183, which is Calculus 1. We are from JCS 110-B. So, the first one is me, Muhammad Ikhwan. The next one is Farhan Daniel. And the last one is Muhammad Imtiaz.
Hello, my name is Farhan Daniel Fazil and I'm with my clone. Hi. So today I'm going to talk about what is differentiation and why we use differentiation. So, what is differentiation? Differentiation of application is a process of finding the derivative or rate of charge of a function in contrast to the abstract nature of the theory behind it. The practical technique of differentiation can be carried out by purely algebraic manipulations using three basic derivatives, four nature of operation, and a knowledge of how to manipulate functions. Plus, related rate is one of the application in calculus. One example of application in real life using related rate is we can find out the speed between two persons that running in different directions if each of the person's speeds and direction are known. So Farhan, why we use differentiation? We use differentiation to determine if a function is increasing or decreasing. The function is increasing if the derivative is always positive. Meanwhile, the function is decreasing if the derivative is always negative. The reason why we use differentiation of application is because differentiation can help us to solve many types of real-world problems, such as calculate cost, strength, amount of material used in a building, and other things. Besides, differentiation also helps us finding a function that outputs the rate of change of one variable with respect to another variable. So that is the answer for the why we use differentiation and what is differentiation. Now you know why we use differentiation application. Next, my other friend Imtiaz will explain the problem and step by step on how to solve it.
Okay, now I will continue with the problem statements. The situation is a spherical snowball melts at the rate of 4 pi centimeter with the power of 3 per hour. It melts symmetrically such that it is always a sphere. How fast is its radius changing at the instance r equal to 5 centimeter? Before we move to the solution, let me tell you about problem-solving strategy for the related rates topic. There are 4 main steps that we should know. Step 1. Draw a picture of the physical situation. Step 2. Write an equation that relates the quantities of the interest. Step 3. Take the derivative with respect to time of both sides of your equation. Remember the chain rule. Step 4. Solve for the quantity you're after. So let's start the solution. The first step. Draw a picture of the physical situation. Based on the situation, snowball melts. As we all know, snowball has a spherical shape. So, we have to draw a sphere. Next, we have to collect all the information from the situation. The first information is radius. Radius or r is equal to 5 centimeter. As this situation said, the rate of change is 4 centimeter cube per hour. So, our dv over dt is negative 4 pi. The value is negative because the snowball is melting. Then, what are we looking for? We are looking for dr over dt. The next step, write an equation that relates the quantities of interest. In this step, we must always remember the formula. So I will tell you, the formula for volume of sphere is V equal to 4 over 3 pi r cubed. Then, we have to differentiate the formula. Let me show you how to solve it. The first step is, we have to write dv over dr equal to 4 over 3 pi r cubed. In this step, we just have to copy back the formula. Next, we have to differentiate the formula as usual. First, bring the power of 3 to the front, and the power will minus by 1. You will get 3 times in the bracket 4 over 3 pi r with the power of 3 minus by 1. The answer is 4 pi r square. The third step, take the derivative with respect to time of both sides of your equation. Remember the chain rule. In this step, we will use the chain rule. What is chain rule? Let me show you which one is the chain rule. First, we have to write the formula. The formula is dv over dr equal to dv over dt times by dt over dr. From the previous step, we already have the value of dv over dr, which is 4 pi r square. We also already have the value of dv over dt, which is negative 4 pi. So, we just have to transfer the values into the formula. You will get 4 pi r square equal to negative 4 pi times by dt over dr. In this step, we have to find the dr over dt. So, first we have to bring the dr to the left, and we will get 4 pi r square times by dr equal to negative 4 pi times by dt. But we have to let the dr over dt alone. So, we have to move dt to the left and 4 pi r square to the right. And the final answer we will get is dr over dt equal to negative 4 pi over 4 pi r square. Next, the last step, solve for the quantity you're after. In this step, we just have to solve and everything is done. Let me show you. Based on the situation, the value of radius given is 5. So, from the previous equation, which is dr over dt equal to negative 4 pi over 4 pi r square, we have to transfer the value of radius, which is 5, into the equation, and we will get negative 4 pi over 4 pi times by 5 with the power of 2. And the final answer we will get is negative 1 over 25 centimeter per hour. So, this is the solution for the situation. Easy, right?
Next is conclusion. From the calculation above, we found out that the rate of change is negative 1 over 25 centimeter per hour. The negative value indicates us that the snowball is melting as the volume of spherical snowball is decreasing. It shows that the application of differentiation can be used to find the exact rate of change. The last one is references. These are the references that we use for this project.
That is all from us. Thank you so much. Have a nice day.